Okay, so this is a video explaining the spatial validation process that we're going to complete on each set of reports for a company. So you get a bunch of DEOs and a bunch of folders. Temp folder is just a working directory for any working directory. Prospects is a placeholder. We'll move to digitizing prospects and down the track. Pre-existing data contains drill holes that the client may already have in their area, and tenements restricted contains the tenements known for that company or for those reports, but it's not reliable. It was collected by digitizing old maps and maybe unreliable, and also the shapes have changed over time, so we can't rely on it. But it's just there in case you need to just quickly work out where you need to zoom into. Local transformations is in the new local transformation. We want to use the new local transformations transformer and shapefile, which is using MGA94. And then we have georeference images. So the georeference images that were provided by the person doing the work. And then we've got a bunch of DEO shapefiles. Now these DEO shapefiles were generated by a script that I made in Python, which needs a little bit of tweaking, but it's a starting point. So I'll provide the shapefiles that's been provided, but as you go along, you may need to make your own shapefiles for different bits of the DEOs, and I will explain that as I go along. So we're going to validate and do the final validation checks inside this folder. And then once it's done, we'll migrate it over to a final kind of structure where it's going to just do a final QC test before it gets pushed into the database. So the first thing we're going to want to do is just create an MXD inside this folder. So we will just open up ArcMap. We'll attempt to streamline this process a little bit down the track, but obviously it's a bit of a work in progress. And as we do these the first time that we do these, then it's a little bit of a tweaking and sorting out our processes as we're going along. But this will get us moving in the right direction. Okay, so we've got an untitled ArcMap, so we'll just go and we're going to add in our base map. And we're going to add in our base imagery. Okay, the order that we just added them in is somewhat significant because adding that New South Wales base map in, as I explained in that document, will set the data frame to that system. So I'll just pause this. Sorry, I'll just pause this. And if we go on to view data frame properties, you'll see that the data frame is set to this WGS84 Web Mercator auxiliary sphere. So that's a world geographic system. It's a WGS84 world system Web Mercator auxiliary sphere. So that's the system that the data frame has been set to, which is all fine and dandy. So then we can add in all of the shapefiles. So if we just sort the files by shapefile, we can just drag in all of the shapefiles for all of those DEOs, just whack them into our workspace. Now it's going to come up with a transformation warning, and it's going to say that we're going from GDA 94 to WGS 84. There's no conversion necessary to go from that to that, so we can just leave it as none, go OK and close it, and our points are going to appear. If I turn that off and unpause that and zoom to one of these, zoom to layer, that one's only got 2 in it, zoom to layer is better. So there are points there. So that's the points that have been extracted from all these different DEOs, okay? Either surface samples or drill hole collars. So there are points, and now we want to bring in our maps. So in this instance, we've got one map and two maps georeferenced and one map ungeoreferenced. That one was georeferenced, but it needs to be looked at again. So we'll go through the process of doing that as part of this. So bring in 11, if that's worked. So this one is saying it needs to go from GCS 66 to MGA 94. So if you've got your custom one set up, then you can use your custom one that was set up when we did that new system coordinate thing. If you haven't done that, then what you can do is you can just go on new, and then you can change it to a coordinate data frame, and then just type in all the numbers in there, and then give it a name and save it. So I'll go OK, assuming that that is all being done correctly, and go close. So that's brought our map in, and it looks like it's sort of not plotted in the right place, which is very helpful. But that's okay. We're going to come across these problems as we're doing this anyway. So we've got that map, and let's bring in the other map. So our other map, 35. And it's warning us, this is in 1994, GDA 1994. So GDA 1994, WGS 84 does not need a translation, so that's fine. So it's just warned us of that, okay? So we'll just go OK, and we'll go close. Right. So now we're in, and we'll turn our maps off, and we'll put them to the bottom of our workspace so we can see what's going on underneath, and then we'll make them transparent. So if we go in here, we go in general, should be a transparency thing here somewhere, display transparent, we'll make it 50% transparent, make this one 50% transparent, so it's 500% transparent, 50% transparent, apply, okay, alright, cool, and we'll turn these off just for a sec. And now if we look at this map, and we look at this map, so this map has the local transformation points on it that we use to do the transformation. So if we go back into our working folder, I'll just close these other ones down so that there's confusion. Okay, we've got local transformations, got a local transformations shapefile. We'll bring that in. Okay, so the local transformation points is in 1994, and we know that 1994 to 84 is nothing, so we can just go close and OK. All right, now, if there are local transformation points, then this is the first thing we want to be checking against the map, see which points they've used. So in this instance, we've used they've used that point. And if we go on label features, and then go properties, and then go labels, and then define classes differently, and just go add and call it lock east, and show the lock east, and then add lock north, and go OK, and make that lock north. So now we've got lock east, lock north. On our lock east, we'll place it, the label up there, and on our lock north, we'll place it. Oops, did that the wrong one, didn't I? Lock east, lock north, we'll place it. We'll place it down there, and then they won't conflict one another. Wake and bold and 10 and red. You could probably save this as a layer file, then we'd have to keep redoing this. 10 and bold and red. Apply, okay. Alright, cool. So now it's saying 2200, 2200, 2350, 2350. So we can check the local coordinates are hunky-dory, but when the person did the local coordinate check, they should have been checking that, and they should have been checking the distances, and all of that stuff was correct. So we've got our local transformations. We've got the Kaiser grid and the Bodangora grid, and there are points, right? So we're looking at this map 6371. So the next thing to check is to look at the base map and see how accurate the rectification has been. So on this one, we'll zoom out a little bit. I've got it turned sort of on and off. Sorry, made transparent. So you can see that it's matching up pretty closely because all of the road underneath there, it's matching up pretty nicely, like over there, sorry, over there. And the roads, see the road is sort of not, the map is not super accurate, but that's because it's just an old map, right? But it looks like it's all very close. Different bits are in slightly different positions, but the main points are all matching up. So that grid line is there, and the grid, and So it's all looking good. Okay, so we don't need to mess with this particular map. And then if we plot up the 6371 surface samples, and we look at the transformation that was completed, it's actually looking very good. The ends of the lines, the points, it's not going to be exactly, but I think the distance between there is like 20 meters, and so these ones looking like we're sticking out. It'd be worth just checking on those. So if we do an information on, say, that one, for instance, we should be able to get up what the local leasing. See, it's saying local leasing 4,000. So our baseline for the grid baseline is, that's one. I'm just trying to find the baseline here. What does it say? Okay, so that baseline there is 3,000. So the distance to that point should be about K. About K, should be exactly a K. So we'll just measure it and make sure. So basically what we're doing is checking to why have we got points that aren't plotting on that grid. If we look, so it says 1,200 or thereabouts. So it's pretty close. It's a little bit out. Local east 4,000, and that was 3,000, wasn't it? So, but it's not terrible for a local grid transformation. And the points are all basically like lining up nicely where they are. That's like the most extreme distance away from where the actual transformation was. So the further you get away from it, the more inaccurate it gets. So in this instance, happy with the local transformation for all those data points. So if we go into the DEO of that file, 6371 DEO, and we're looking at the surface samples. So surface samples A, and we scroll across. Sorry, that's surface samples A. Scroll across. So we can see that we've got good documentation. I'm going to pause the video before it gets hit 15 minutes. But we've got a good comment in there saying which transformation was used, and we've got the grid name and the locals and a pickup of the easing northings, which we know are applying in the right place. So all of these ones are good. So we'll just highlight them and flag them as good and save it, and I'll stop.